Welcome to calculus class. This is going to be a topic that is not necessarily an objective in calculus, but a lot of trigonometry is used in calculus. And in the past, a lot of what you have done in calculus has been memorizing the unit circle or pulling out the unit circle whenever it came time for that on the test. Well, in calculus, we don't get the advantage of using the unit circle. And outside of that, there is a lot to memorize if you don't know the unit circle. So we're going to look at a couple of things that will help you to remember all of the trig functions in the various quadrants and the radian measure, shortcut to knowing where your radian measure is at a particular point, and so forth. First thing I'm going to do is going to break down the unit circle where the values would be, not looking necessarily at the radius of 1, but just at the angles. And we're going to see some things from the angles that will help us to be able to set up and know what the different trig values are of different angles. And we're just going to be looking at all of your special angles, your 30s, 45s, 60s, and 90s. Your 90-degree angles are called your quadrantal angles. They go with 90 and pi over 2, 180 degrees and pi, 270 degrees and 3 pi over 2. And of course, there's 0 degrees and 0, which could also be associated with 360 degrees. So those are going to be your basics. The key to know in doing what I'm going to introduce at first is understanding the correlation between 180 degrees and pi. Now, let's go from there and let's talk about it. There are a few patterns that exist on the angles connected with the unit circle. The first thing to consider is that these values, think about them as being parts of 180. Because 180 is 1 pi. 180 degrees, I should say 180 degrees is 1 pi. So what's happening here is, to know where they are, you think about the relationship from 30 degrees to 180 degrees, or just 30 to 180. 30 is 1/6 of 180, therefore it goes with a pi over 6 value. If we think about 120 degrees, 120 is 2/3 of 180. So 120 degrees would be associated with 2/3 pi. So if you think about the portion, especially in the first and second quadrants, if you think about the proportion that those values are to 180, just stick a pi with it and you've got your radian measure. 135 is 3/4 of 180, so it's going to be 3 pi over 4. So that's going to be one thing to go with, and it works in the third and fourth quadrants as well. It's a little less obvious because these would be considered improper fractions, even though I don't like that term, improper fractions, but these would be improper fractions associated with the pi value. But still, it's the same thing. If you think about 210 degrees is pi plus 30 degrees, which is 1/6 of pi, so pi plus pi over 6 is 7 pi over 6. So again, think about the relationship of these values to 180, and that will help you to be able to set up and know your angles better. Now, there are a couple of other patterns that exist here that are key, and I don't remember anyone ever teaching me this. I think I just was in search of shortcuts anytime I could get them, and I kind of figured out on my own some of the patterns that we're developing here. The pattern in the first quadrant is you just take pi over whatever that fractional value is. So 60 degrees is 1/3, so it's just pi over 3. So what these have in common in the first quadrant is It's just 1 pi over the denominator's value. You go into the second quadrant. The second quadrant, your numerators are 2, 3, and 5. Now understand, this does not work for every angle in the second quadrant. It just works for your special angles, and that's what we're going to be concerned with in this class as far as being able to do these problems without calculators. So, looking at the numerators here, your numerators are 2, 3, and 5. Your denominators are 3, 4, and 6. So if you look at the pattern that's happening there, your numerator is always 1 less than your denominator. So with your denominator of 6, it would be 5 pi over 6. Where your denominator is 4, it's 3 pi over 4. Now, 90 degrees shares a commonality with both of these quadrants. In the first quadrant, if you look at it, we got a single pi in each one of the values. Well, this is a single pi. And also the numerator is 1 less than the denominator. So we have pi over 2, 1 pi over 2. So the second quadrant fits the characteristics that I just mentioned about both the first quadrant and the second quadrant. And again, the trick of knowing all this is to know that 180 degrees is equivalent to pi. Now, let's go into the third quadrant. And again, picking up the patterns, you go 6, 4, 3, 2, 3, 4, 6. So we're going to have the same thing here. 6, 4, 3, 2, 3, 4, 6. That's going to be the pattern that your denominators hold up to. And I think that you could probably see the relationship with the numerator and the denominator here. And that is, again, that the numerator is 1 greater than the denominator. So in the third quadrant, your numerator is going to be 1 greater than your denominator. Now again, that works for the special angles. It would not work for 190 degrees. Now let's go into the fourth quadrant. And in the fourth quadrant, your numerator is 1 less than 2 times the denominator. So if you have 3 times 2, it's 6. 6 minus 1 is 5. 4 times 2 is 7. 4 times 2 is 8. 8 minus 1 is 7. 6 times 2 is 12. 12 minus 1 is 11. So that's where your numerators come in your fourth quadrant. And once again, your quadrantal angle of 270 degrees shares common things with both of them. 3 compared to 2, 3 is 1 greater than 2, so 3 over 2. Or what do you get when you double 2? 2 times 2 is 4, 4 minus 1 is 3. So this characteristic fits both of those characteristics in the third and fourth quadrant. Now, in this class, there may be one problem we work throughout this class where we use degree values. So, go ahead and get that calculator geared into radian mode, because that's where you're going to be dealing with in here. But again, this is going to be, we're going to look at these special angles without a calculator. So let's say we need to know something about the sine of pi over 6. Okay, the sine of pi over 6. Well, if you think about you've got 2 special right triangles. You've got your 30, 60, 90 triangle, and then you have your 45, 45, 90 triangle. Now, I'm going to use this, instead of the unit circle, I'm going to use these 2 triangles to calculate every trig value in this circle with the exception of my quadrantal angles. So let's look at these 2 triangles here. Now, again, the setup is important. The setup is crucial to this. Now, here are my hints for my setup. Okay. In both triangles, you have an association of a 2 with each hypotenuse. Now, it just so happens that the hypotenuse in this triangle, it's not 2, but it is the square root of 2. But still, you've got a 2 with the hypotenuse there. In this triangle, well, also, 3 of the 4 legs, when you think about both special triangles in common, 3 of the 4 legs have a 1 with it. The only thing that's missing from here is, and I'm hoping some of you are trying to play along as I'm going through it, so if you can try to remember it, that's great. I'll give you a second. But if you don't remember it, it's the square root of 3. Now, let's just say you forget that that's the square root of 3, and you're like, oh no, I'm stuck. No, you're not, because you know the Pythagorean theorem. And you know that a squared plus 1 squared equals 2 squared. So you have a squared equals to 4 minus 1, so a squared equals 3. So a would equal 2, and typically you'd say plus or minus that square root, but because we know we're dealing with the length of a triangle, the only appropriate answer here is the square root of 3. So if you forget that this is the square root of 3, you can always go to the Pythagorean theorem to solve that value out. So now we've got our 2 special right triangles set up. So what we can do here is now associate this. Okay, so we've got pi over 6. We need to know the sine of pi over 6. Well, I get to the sine of pi over 6, and I think, okay, 1/6 of 180 degrees is 30 degrees. So I know that finding the sine of pi over 6 is the same thing as finding the sine of 30 degrees. And what is the sine of 30 degrees? Well, sine, here's 30 degrees. It's the opposite over the hypotenuse. So the sine of pi over 6 would be 1/2. Again, that's all that. I don't have the unit circle drawn. I don't have my calculator out. I just have these 2 triangles right here memorized or learned. I hate to say memorized because I memorized the preamble to the Constitution, and I've since forgotten it, but I have not forgotten these triangles. That's a shame to say. I wished I had not forgotten the preamble. But anyway, getting back to this. Every once in a while, y'all may notice that I can get off topic. So, we're looking at these 2 triangles here. So let's pick a different one. Let's get to a different quadrant. Let's say we're interested in 5 pi over 4. Okay, well, I need to go from 5 pi over 4. Now, I'm not going to do, you could do a multiplication of 180 over pi, cancel your pi's out, 4 into 180 is 45, 5 times 45 is 225, and get it like that. And that would be perfectly fine. But there's another way I want us to think about this. If you think about this setup as, okay, it's 5 pi over 4. The numerator is 1 greater than the denominator, so we know we're in the 3rd quadrant. So I'm going to draw me a 3rd quadrant triangle, and I also know 1/4 of 180 is 45. So I know I'm talking about a 45-degree angle in this triangle, so let's set it up. Again, 45, 45, 90 is 1 square root of, 1 square root of 2. And in the case here, I know that this is negative and this is negative because you had to go back 1 and you had to go down 1. So let's say we want to know the cosine of this angle. Well, the cosine of, again, this would be 5 pi over 4, is cosine SOHCAHTOA. Cosine is adjacent over hypotenuse, so it's -1 over the square root of 2 which would become this negative square root of 2 over 2. And there you have, your solution for the cosine of 5 pi over 4. Again, what did I do? All I did was associate this fact that 4 is in the denominator, so I know I'm talking about a 45 degree. Numerator is 1 greater than the denominator, so I know I'm in the third quadrant. And past that, I use one of these two triangles to label it, and I'm there. Let me do one more for you. Let's go with 11 pi over 6, and let's do tangent. We want the tangent of 11 pi over 6. Double your denominator, you get 12. 12 minus 1 is 11, so we know we're in the fourth quadrant here. So drawing a triangle in the fourth quadrant, and when I draw that triangle in the fourth quadrant, I know over 6, 1/6 of 180 is 30, so I know I'm talking about a 30-degree angle here. And from that 30-degree angle, I'm going to put opposite of 30 is 1, hypotenuse 2, square root of 3 here. So let's say we want the tangent of this. This one's negative. So tangent is opposite over adjacent. So I've got negative . And y'all do the same thing. If y'all make a mistake, just erase it with your finger as well. Negative 1 over the square root of 3, and when you rationalize that, that's the negative square root of 3 over 3. And you have it from there. So I'm going to link in the text box below some problems that I want you to do on your own. Again, this is just to practice with learning the trig values in the unit circle without actually drawing out the unit circle. Typically using these two right triangles to get there. The main difference here is if you think about something that's on the quadrantal angles or the quadrantals, here think about opposite over adjacent or whatever. Here your opposite side, if you think about what your opposite side is your vertical. So let's just say your opposite side would be 1. Your adjacent is associated in both of these problems. Your adjacent is associated with what runs along the x-axis. And if you're at 90 degrees or if you're at 270 degrees, the adjacent is going to be 0. Now here I'm going to say my opposite side is positive 1. Here I'm going to say my opposite side is negative 1. It's negative because you would be going down to get to it. And your radius is always your distance to your point. So again, let's just say that your radius, which is your hypotenuse, is 1 here. Your hypotenuse here. Now your hypotenuse is always going to have a positive value because your hypotenuse is your distance from the point back to the origin. So along the x-axis here, your opposite here, you're not going up or down, so your opposite's 0. Your adjacent, you're moving along the x-axis, and you do move along the x-axis to get to 180, but to get to 180, you move backwards, so let's just say that's negative 1, and your hypotenuse here would be 1. Here, your opposite, again, going up and down 0. Adjacent, you're moving to the right, so we would have a positive value. Let's just say it's positive 1. And your hypotenuse, again, is the distance to that point, so it'd be 1. So if we wanted to know, like, the cosecant here, cosecant of theta cosecant is the reciprocal of sine, so it's the hypotenuse over the opposite. Hypotenuse over the opposite would be 1 over 0, which is undefined. Sorry. And over here, let's talk about the cotangent. So the cotangent here, cotangent's the reciprocal of tangent, so it's, instead of opposite over adjacent, it's adjacent over opposite, so it's negative 1 over 0, which is also undefined. Let me try to pick one that's not undefined here. They're not all undefined. Let's just talk about sine here. Sine of theta. Okay, your sine of theta here, you're talking about opposite over hypotenuse, which is 1 over 1, which is 1. And let's talk about your cosine here. Your cosine is adjacent over hypotenuse. So your adjacent's 0 and your hypotenuse is 1, so you get 0 there. So those would be your quadrantal angles. A lot of times people find it easier to memorize the quadrantals and derive those. Just got our AP scores back this morning from last year, and I know talking with the students last year, trigonometry values and non-calculator problems were what got them the most. And I didn't really go over this with them in a set lesson. I'm doing that with y'all, so hopefully you can get this. Like I said, I'm going to link either down below or on your Canvas page some problems for you to try on your own and see how that goes. Thank you. I hope that you're not having to watch this video, because I hope I am back in class by now. But if not, this would be a good video for you to watch on your own if you don't pick up everything in class. Have a good day.